All right, guys, welcome back. More with scientific notation today. We're going to continue working on expressing numbers in scientific notation, converting back and forth, and then comparing and ordering numbers in scientific notation. And finally, we will use scientific notation to write estimates of quantities as well. So let's do a quick little review of how to write things in scientific notation and what it really means. So let's see if we can do these two warm-up examples here. So part A, we want to rewrite the number 353 million in scientific notation. So remember scientific notation again, the deal is that we need to have a number between 1 and 10, and then we will multiply that by 10 to some power. So looking at this number here, it looks like we would need to have the decimal place in between the 3 and the 5 there. Okay, that's the only place that would make this number between 1 and 10. It cannot be 35.3 or 353. It needs to be 3.53 times 10 to the, and let's see if the decimal place was here. We had moved it 1, 2, 3, 4, 5, 6, 7, 8 times. So this number in scientific notation would be 3.53 times 10 to the 8th power. Okay, and then in another example, how about 16 times 10 to the 7th power? Okay, anybody there thinking that kind of looks like scientific notation? And it kind of does, you're right. But the problem is that this number is not between 1 and 10. Okay, so we can't write it as 16 times 10 to the 7th power. So it's going to need to be written as like 1.6 times 10 to some power. And sometimes to figure out that power, it's helpful just to convert this to standard form first. Okay, that's something we should know how to do as well. Standard form is just write the number with all the zeros and whatnot. So right now our number is 16, and then we're going to be moving the decimal to the right 7 times. So that's going to add 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, now to get that back into scientific notation, again, we know it needs to be 1.6 times something. So if the decimal point were there, it would be how many numbers after the decimal? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that would be scientific notation for the original problems. Okay, so I just wanted to point that out, make sure we're clear again that that factor there needs to be a number between 1 and 10. All right, so let's take a look at a couple other examples here. Can we convert these numbers to scientific notation as well? Okay, so same kind of concept. Again, it needs to be a factor between 1 and 10 times 10 to a power. So in part A here, it's 0.125. So that's not between 1 and 10, but 1.25 would be. So that's going to be our first factor, and times 10 to the, now think about this one's a little different than what we saw. The decimal place was between the 1 and the 2. It actually needs to be one space to the left. Okay, so to get the number to become smaller and move the decimal to the left, what we're going to do is we're going to make the exponent negative. Okay, so this would be 1.25 times 10 to the negative first power. Okay, let's do a few more examples. Part B there, 0.00006. Okay, so I know it's going to be a factor of 6 times 10 to the, and let's see if the decimal was there, and it moved 1, 2, 3, 4, 5 spots to the left, it would need to be times 10 to the negative 5th. Okay, how about just the number straight up 7? Okay, 7 times, how are we going to do this? Times 10 to the 0 power, right? Because remember, think about, and that one's a little tricky too, but if you think about 10 to the 0 power, in the previous section we knew 10 to the 0 power is really just equal to 1. So this is really just saying 7 times 1. Okay, and if you are forced to write something in scientific notation, you would have to make it times 10 to the 0 power for that example. Okay, and of course most people are just going to write that number as 7, but if you have to do scientific notation, that's what we need to do. All right, and then part D, you got a bunch of zeros there. So we're going to think about the factor again is going to have to be 2.5, because that's the number between 1 and 10. Now let's figure out if the decimal was right here, how many times did it move? So how many numbers are to the left? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to multiply the 2.5 times 10 to the, since it went left, negative 11th power. All right, so just be careful counting those numbers there. All right, so let's move on. Let's see if we can now order some numbers, okay, in scientific notation from least to greatest. Okay, and let's do it, maybe do it the long way first, just the kind of safe way. Let's write each of these numbers in standard form, and then it's going to be easy to compare them, and then we'll see if there's a way to do it without that. Okay, so example A, 8 times 10 to the 0 power. So remember, 8 times 10 to the 0 power. 10 to the 0 power is really just 1. Okay, or you can kind of think of it following the same procedure. The exponent is telling you how many places to move the decimal, so we're not moving it at all. Okay, so it's just staying as 8. 9 times 10 to the negative second power would mean, let me just do this up here. If we had 9 and it was times 10 to the negative second, we need to move the decimal to the left because it's a negative exponent 2 times. Okay, so this is going to become 0.09. And then the third number, 2 times 10 to the third. Since it's a positive exponent, we're going to move to the right 1, 2, 3 times. 1, 2, 3. So 2,000. Okay, now if we need to order these numbers, so the answer, that was just kind of doing some work over there, but the final answer in order, we want to go from least to greatest. So the smallest number is 0.09, then 8, and then 2,000. Okay, so those, again, let's kind of write them how the problem was given. The smallest number was 9 times 10 to the negative second power. Then the answer, or the number 8 times 10 to the 0 power was next. And then 2 times 10 to the third. Okay, and let's just take a look now. Anyone see a way, how can we use those exponents on the 10 to kind of know the answer without even really having to go to standard form? Okay, if you take a look, these exponents, that's the smallest, then 0, and then the 3. So we kind of could have been able to get these in order without necessarily having to convert to standard form first. But it's not a bad idea, and it's good practice. Okay, let's do one more. Why don't we do D down there? So let's see, can we order those numbers from greatest to least? So try to switch us up there. All right, so not every number is in scientific notation. Okay, so this time maybe we'll just convert the ones that are into standard form just for fun. So let's just rewrite them in standard form. So 1 times 10 to the 0 power again is just 1. The 0.87, that's already in standard form. And then 7.8 times 10 to the first means we're going to move that decimal 1 time to the right. So that number is going to be 78. Okay, so if we need to order these numbers again now from greatest to least, this one said, the biggest one is of course the 78, which was this, so 7.8 times 10 to the first. The next biggest was the 0.87. I'm sorry, what am I talking about? The next biggest is 1, right? And then the least is the 0.87. Okay, so just kind of know how to convert back and forth. We can get these numbers in order, and that's how we do it. All right, and one other thing we can do in here, we can use scientific notation to write estimates of small numbers. Okay, I know in the first section we did this for large numbers. So you can kind of do the same thing. Let's say example B here, a micrometer is a small metric measure for length. Using her computer, Jenny found that a micrometer equals 0.000039 blah 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 of an inch. Okay, let's use scientific notation to estimate the inch equivalent of a micrometer. So basically it's boiling down to they want us to write this number in scientific notation, okay, and just to estimate it so we don't have to write all the places. So what we're doing, we're looking at this, how this, the greatest place value here, we see this first digit is a 3. That's going to be in the 100,000th place. So since it has a 9 after it, we're just going to round it up to 4. And we'll just leave the zeros before it. So we have 0.00004. That's an approximate value. Okay, that's an estimate for the number in standard form. So then in order to write it in, again, scientific notation, all we need to do is write it as a factor of something between 1 and 10. So we're just going to use 4. And we're going to simply count how many digits there were before the where the decimal would be. So if it was right after the 4, and we count 1, 2, 3, 4, 5 times, that's why we end up with a -5 as the exponent. Okay, so let's do a couple on our own and see how we're doing here. So this number, 0.00018, okay, so we're first going to round it, okay, and get an approximate number in standard form. So it looks like the first digit is tenths, hundredths, thousandths, 10,000ths place. So I'm going to keep the 3 zeros before, and then since it's 0.18, I'm going to round that 1 up to a 2. So there's the number in standard form, rounded. And now we just need to write that in scientific notation. Okay, so it's going to be 2 times, and let's think about it. If the decimal was after the 2, it moved 1, 2, 3, 4 times to the left. So we have a negative exponent of -4. Okay, so it's approximately 2 times 10 to the -4th power. All right, and then the last one over here, 0.00619. So the 6 right there is going to be our first digit. So that number, if we were to round it, would be approximately 0.00. Now the 6, there's a 1 after the 6, so I'm going to leave this as 6. And so that means it's going to be 6 times 10 to the, let's think about the decimal, if it was after the 6 and now it's really 1, 2, 3 to the left, we're going to have an exponent of -3. Okay, so just a quick recap. To do this kind of thing, just with the negative exponents and positive exponents, for example, let's say it was 3.52 times 10 to the 4th, versus 3.52 times 10 to the -4th. Okay, the only difference is the way you move the decimal. Okay, when you multiply by 10 to the 4th power, we are moving the decimal 4 places to the right. 1, 2, 3, 4. So we're going to have 2 additional spots that we will fill in with zeros. Okay, and while the other one, 3.52, if we move, or if we have a negative exponent, that means the number needs to get smaller, so the decimal goes to the left. 1, 2, 3, 4, and we fill in the little place values with zeros, so we have 0.000352. Okay, so just focus again, having a factor between 1 and 10, and then just watching if the exponent's negative or positive, and that is scientific notation.